All right, here we go. Your 2, 4, and 2, 5 notes. Um, Finding maximums and minimums. So um, on a quadratic function, a parabola, the maximum and minimum occurs at the, hopefully you're figuring this out, but it occurs at the vertex. The vertex. So if I had a parabola opening upward, its maximum, it continues going on up forever, so it's either no maximum or in positive infinity, depending on how you want to view that one. But its minimum occurs right there at the vertex. Likewise, if it's opening downward, it's either got no minimum or a minimum at negative infinity. Again, kind of however you want to view that. And then the maximum is again at the vertex. So we've got maximum and minimum. All right. The maximum, if the parabola opens downward, and the minimum if the parabola opens upward. So opening upward has a minimum, opening downward has a maximum. Now cubics, they're going to be able to turn more than just the one time. And so they'll have local minimums, and so cubics or a higher degree, sorry, or a higher degree function, and they'll either have a local minimum or a local maximum that it turns that will occur every time the graph turns. So for example, you may have a cubic function that looks something like this, and you'll have a local maximum right here, local maximum. It's the maximum at this local area right here. And then over here we've got a local minimum. It's not the lowest point on the entire graph because down over here we've got some lower values, and this local maximum isn't the maximum point on the entire graph because again we've got some greater um, output values up there. But every time that it does turn, you've got another local minimum or maximum. So the maximum number of turns, we're on this part right here, the maximum number of turns for a polynomial function is one less than the degree of the function. You won't always have that many turns. You could have fewer, but the maximum number of times that a polynomial function is going to be able to turn is one less than the degree of the function. So if it's a fifth degree function, it could turn up to 4 times. If it's a 10th degree function, it could turn up to 9 times. It could turn less, but the maximum number is going to be one less than the degree of the function. And so here's just an example here at the end. And it says, what is the maximum amount of turns or local maximums and minimums that can occur for the following polynomial function? And really all we're looking at here is just that leading term. This is a fourth degree. And so first off, we have already learned how um, its end behavior is going to be going the same direction. And specifically, it's got a positive leading coefficient. So it's going to end going positive or begin at positive infinity and end at positive infinity. Now, in the main time between these two ends here, it's going to be able to turn a maximum of 3 times, and it may not turn all 3 times, but it can turn up to 3 times, which is going to make sense. Let's say it came down, headed up. There's one local minimum, came up, headed back down again. Now we've got a local maximum. And we know it's going to have to end going towards positive infinity, so maybe it comes down for a bit and then heads back up with another local minimum. So you can have multiple local minimums and multiple local maximums, just depending on your graph. And so again, the maximum number of turns, so here it turned 3 times, is going to be one less than your degree of the function. All right, I hope that helped.